Our next video is on congruence and triangles. We'll be learning about ways that triangles are congruent, corresponding angles and corresponding sides of congruent triangles, naming triangles according to congruent statements or markings on drawings. Congruent triangles are used in a variety of ways, including architecture and construction. Congruent shapes mean exactly the same size and shape. We often think of congruence as same size, same shape, and similarity as same shape, different sizes. There are corresponding angles which are congruent and corresponding sides which are congruent. Corresponding means that we match them up. Example, on this I have different sides and angles marked on the drawing. According to the markings, we'll list the angles and the sides that are congruent. Let's look at the markings. We have 1 and 3 markings. I'm going to make a congruent marking on this angle. Same thing where I see 1 and 3 markings in between there, this would be the angle. So angle A is congruent to angle Z. Then where I have 1 and 2 markings, I'll make 2 congruent markings. Between 1 and 2 side markings, I'll make 2 congruent markings on the angle. Angle B and Y are congruent. And finally, I have one angle left, angle C. I'll put 3 markings on angle C, which will correspond to angle X in the other angle. So C and X are congruent. Now we do the sides, or segments. We have A, B, we list it as a segment, is congruent to, notice I went A and then B, I have to match up over here with the angles and the sides, so Z, Y, not Y, Z. Next we'll have B, C. If I use the side in that order, I have to then name the other one in the same order. 2 to 3 markings. 2 to 3 markings here would be side or segment Y, X. And then finally, for our third side, if I use AC, that's 1 to 3 markings. I'll do the same thing here. ZX is 1 to 3 markings. You have to have things in the correct order when you do correspondence of angles. It's very important to make sure you're matching up the correct angles and the correct sides in congruent triangles. When I name the triangle, wherever I start, A, B, C, in that order, has to be where I start on the other one so that the sides and angles all match up. So I have triangle ABC. If I say ABC in that order, then it would be Z, Y, X over in the other triangle. And by writing this congruence statement of triangles, that should tell me which sides and which angles match up and correspond by the order. If I had said, for example, triangle CBA, I would have to say triangle XYZ on the one on the right. The third angle theorem tells us if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are also congruent. My example goes with the picture. If angle A is congruent to angle D, and angle B is congruent to angle F, then angle C, my third angle, is congruent to angle E, my third angle here. We know that also because the 3 angles of every triangle must equal 180 degrees. Let's look at this right here. No picture, just order of lettering. The order of the lettering should also tell us what's congruent. So, for example, angle C should correspond to angle T. Angle R should correspond to angle A. If we're given that side AC in that order, AC would correspond to RT, that side. So we know, just by the order of the lettering we're given in our congruence statement, what's congruent. ST would be congruent to BC. RS would be congruent to AB. And angle B would be congruent to angle S in the other triangle. Write a congruence statement for the congruent triangles. we can see what matches up here with the angles and the sides. We need to pick whatever we start with. Let's say I start with B, then A, then C. In the first triangle, I'll list it, BAC. I need to start with the same angle and match up the sides. So I went B to A to C. So here I'll have to go then E to D to F. So there's multiple ways that we can write it. We just have to make sure that we match up the sides and the angles when we write a congruence statement. Notice that this is called a congruence statement. You're writing what triangle is congruent to what triangle. That's different than asking what the corresponding parts are in congruent triangles. Here's another example. Write a congruence statement for the congruent triangles. So again, we match up. If I use A, B, C, for example, in that order, and notice on this one we do have our third angles congruent because we have vertical angles. Vertical angles are always congruent to each other. ABC would match. We want 1 to 2 to 3 markings. I'll do the same thing here. 1 to 2 to 3 markings. So E, D, C. Again, there's multiple ways you can name these. This is just one example of a way that you can name the triangles congruent. Match up your sides, match up your angles, and you should have a correct congruence statement. Here we have an example of two congruent triangles. We're given 3 different sides to choose from and a side with an X. We want to focus on this one, FE. FE matches CB. We have to find that one. That's this side right here. BC or CB is 20. So we want to set 3x minus 7 equal to its corresponding side to be able to find x. Equals 20. Solve for x. Add 7 to both sides. So 3x would equal 27. And divide by 3. X equals 9. On the next example, same idea. We have 2 congruent triangles, so we know that the sides and angles will match. We're looking for AC's corresponding side. AC, look at the order of the lettering here, should correspond with DF. So we want to pick out DF, the one that's correct to match the other side of the first triangle. Since they're corresponding parts, they'll be congruent. Corresponding parts are always congruent on congruent triangles. So we'll set this equal to 16. Add 8 to both sides. 4x equals 24. Divide both sides by 4. X equals 6. And we're done. Last thing we have here are just some congruence properties. They're properties of congruent triangles, similar to properties that we use for finding sides or angles. Reflexive property, these are algebra properties, says anything is equal or congruent to itself. So the reflexive property of congruence for triangles says triangle ABC is congruent to itself. Symmetric property says we can flip things around. If ABC is congruent to XYZ, then we can change the order XYZ and it'll still be congruent to ABC. Our last one, transitive property, we're familiar with this one. We just used transitive property for congruence in our last unit on the angle pairs. If triangle ABC is congruent to XYZ and XYZ is congruent to QRS, then ABC and QRS must also be congruent. And that's it for our lesson for today.